Thank you, Andy, for jumping on, for giving some background. Andy, if he didn't already say it, he's our president at ANCOM. He founded the company. Thank you, Greg, for joining, and El-Kitab and Mats for putting this on. So, El-Kitab, do you have any other words you'd like to start with before we jump in?
Yes, I just would like to thank Mr. Greg and Mr. Andy to join us. And welcome all the people attending now with us. شكرا يا اخواننا للناس اللي انضموا لنا الان. ان شاء الله تستفيدوا من المعلومات اللي بتتقدم الليله باذن الله تعالى. Thank you, Kelsey.
Thank you. So I'm Kelsey Stafford. I'm the Director of Sales and Marketing here at ANCOM. Off screen, I have Mackenzie, who is running the behind the scenes. She will be making sure as people are joining us that she's admitting you. You will all be admitted with your mics muted just to keep background noise out. If you lose connection, we'll do our best to keep on top of when you rejoin and admit you again. Also off screen, I have Braden, who is a part of our sales group as well as our analytical team. So potentially with the questions we have, you may see him step on camera to help answer those. Today, I plan to take you through a PowerPoint. The first will give you a little bit of background of who ANCOM is. I have a video to share with you. And then I will go into our equipment that we use for crude and detergent fiber determinations. We'll pause for questions, and then I will go into our fat instruments for both crude and total fat. For questions, please utilize the chat as we go. You can type your questions there either in English or Arabic. El-Kitab will help me and by translating for you if that's easier for you to write in Arabic. And I will do my best to present all of our equipment to you and answer your questions. So I think without further ado, we'll jump in and I will share my screen. I'm going to pull up my PowerPoint here. So you should be seeing my PowerPoint right now. So this first video, as I mentioned, I just wanted to play this for you since ANCOM is new to many of you. This is just a great video to show you who we are, our culture, and that we are inventors and we love to automate. So I'm going to go ahead and play that video. All right, so that was just a nice intro video. Sorry if I was talking over the beginning of it, my sound wasn't working, but that video just gives you an idea of who we are, kind of shows that, we take complex analytical methods and we automate them. So this slide here gives you a little bit more of a visual where we take the different sample types, whether it's in animal feed or food, and our instruments in the center here are shown. So we are in everything from crude and detergent fiber, dietary fiber, total and crude fat, vitamins, gas production, and we analyze those sample types to either give you your value or to then isolate the oil or the analyte for you then to further quantitate. So people will go on to fatty acid profiling or find their vitamin peaks on their HPLC or mass spec. So this is kind of the area ANCOM lives in. Please move me forward. So this picture also just gives you a visual of we inform nutritional labels. So whether it's your animal feed label, and again, that's crude fiber, detergent fiber, crude fat, vitamins, we have instrumentation that help find those values. Or if it's your nutritional label for food items, we have instruments that help again with the fat content, your dietary fiber, vitamins, cholesterol, and so on. So the first area I'm going to focus on is the fiber. So I mentioned we do dietary fiber as well as crude and detergent fiber. I'm going to focus on the crude and detergent fibers, which are commonly analyzed in feed analysis, because my understanding is that is the majority of this group. But I'm happy to talk to you, any of you later, if you're interested in dietary fiber analysis. So many of you are probably familiar with the conventional method for determining crude and detergent fiber. It requires a lot of glassware, individual hot plates, beakers, your reflux condenser, your separate filtration step, whether you're using some sort of automated method or semi-automated method through maybe a Foss or a Gerhardt instrument, it still requires that glassware. The filtration step is still can be challenging. There's technician manipulation involved and of course technician error because of the sample transfer. So what we did is we took this automation a step further. We have our ANCOM Delta fiber analyzer that analyzes up to 24 samples at a time, which is about 96 per day. I believe over 100 for crude and detergent fiber per day. This instrument incorporates an internal pump system that draws chemicals from any source within 10 feet of the instrument. So you can see in this picture, your cubetainers are on the underneath the counter, and you have tubes that are plumbed to each of your reservoirs. So whether that's your crude fiber base, your crude fiber acid, your acid detergent, your neutral detergent, all four of those can be hooked up to the instrument at once. The instrument will know, based on your selection, which chemical to pull for the run. Everything is done automatically. The rinses are done automatically. In between your runs, the valves and the tubing will be flushed, so you'll be ready for your next run. And all of this is time, temperature, and agitation controlled because it's a closed system. So what enables this is our filter bag technology, which I will elaborate a little further. But first, I'd like to play a video for you that gives you an idea of how this instrument works.
The ANCOM Delta Fiber Analyzer provides an automated, easy-to-use method for determining acid detergent fiber, neutral detergent fiber, and crude fiber values in feeds and forages. The Delta achieves automation at the highest level with an internal pump system and 5 Easy Connect solution ports. Amylase, acid detergent, neutral detergent, crude fiber acid, crude fiber base. The addition of a transparent side access panel simplifies periodic maintenance and allows the user easy visual access. The internal pumping system allows the user to place any chemical container within range of the instrument for automated delivery. No gravity feed is necessary, therefore eliminating the need to lift heavy chemical containers, and enables the ability to connect the Delta to a larger chemical delivery system. Up to 24 samples are prepared and encapsulated in filter bags. The filter bags with sample are sealed, placed in a bag suspender, and placed into the fiber analyzer's vessel. After the user closes the vessel lid, they follow simple screen prompts to select the desired method and start the run. The Delta's internal pump system automatically draws the appropriate chemicals in the program sequence per the selected method. One of the 5 solution valves opens to allow the pump to draw the chemical required. A fiber optic sensor indicates when the correct volume of solution has been delivered and the vessel is full. During the run sequence of chemical additions and rinses, the non-fiber components solubilize and the samples are filtered. Cell contents are removed while recovering the fiber components to be measured. A direct hot water connection allows the system to automatically flush the input lines and valves. During a crude fiber analysis, the Delta follows the acid step with a series of hot water rinses before moving to the base step. A final series of hot water rinses are automatically performed to complete the process. The multiple chemical connections support seamless transition between crude fiber, ADF, and NDF methods with no need to change out chemicals. After the run is complete, the samples are removed, dried, reweighed, and fiber values determined.
So that video gives you a great overview of what is happening inside this piece of equipment. So because once you put your filter bags inside this equipment, you press start and the user can walk away. So as I mentioned, this instrument is, the automation is enabled through our filter bag technology. Filter bag technology will replace your glassware because each filter bag, you would weigh your sample in, seal it, and then place it in that bag suspender that you saw in the video. This improves accuracy and precision greatly. It allows for larger surface area for the filtration, the full filtration of the sample, as well as complete encapsulation and constant digestion. Because your sample is fully encapsulated, we can put it in the vessel under pressure and high temperatures, and the analysis is done just much more faster with technician-free filtration, and can batch process these samples. So I mentioned we can do up to 24 samples in one run, compared to the other options out there, I believe, are generally around 6 samples per run. It eliminates the technician variability. One thing that we really pay attention with our equipment is trying to make the process as simple as possible, take out as much technician handling as possible, so that way you are able to utilize people of all different levels and skills in your labs to be able to run this equipment and do this analysis. As we all know, labor is the most expensive part of our operations. And so this allows you to be able to train people, again, on all different skill levels, to just have proper weighing technique, seal up their sample in this filter bag, and then place it in the instrument and let the instrument do the rest. So it reduces your cost per assay. It's going to eliminate that glassware for you, and it takes away any sample transfer because the sample stays in the instrument completely from its different, the acid step, the base step, and all your filtration steps. After your run is done, you would simply take the bags out. They'd be dried and weighed for your final result. So we're a part of the AFCO Check Sample program. This is a proficiency testing program in the United States, but is also includes some international participation. It's one of the largest, if not the largest, proficiency program in the world. Many labs all over the country will receive one sample per month to run a certified check sample. And these are just some results that show you how ANCOM performs against other methods out there. So this slide in particular is for crude fiber. As you can see, on average, 68 labs ran the ANCOM method per month, opposed to around 11 labs running the glassware conventional method and 17 running the FOSS. So ANCOM is the predominant choice when it comes to fiber determinations, especially in the feed industry. And this is all really great validation data I'm happy to share with any of you that we have been a part of for several years to just show our consistency and show how precise and accurate ANCOM equipment is in this area. So this slide also shows you our detergent fiber results. On average, 41 labs were choosing to run the ANCOM method per month compared to around 13 labs running the crucible method. And then again, for neutral detergent fiber, on average, 38 labs were running the ANCOM method compared to only 12 labs running the conventional. So this program has a lot of data you're able to reference, and we have these summaries we can share as well to just show really the superior nature of the ANCOM equipment when it comes to other options out there. So I know I moved through that section rather quick. I want to be mindful of everyone's time. I believe we only have an hour. So I'm going to pause and take a look at the chat and just see if there have been any questions on our crude and detergent fiber equipment. Again, this is the ANCOM Delta, so happy to give more information on that. So I'm just going through right now. Thank you for introducing yourselves. That's very helpful. I see a lot of introductions. It doesn't look like we have any questions at the moment. So what I might do, I guess I'll move on. Well, I can move on to FAT, and we can, as you have questions, please put them in the chat, and we can answer questions on any of the topics as we go along. So you haven't missed your opportunity. Okay, so ANCOM also provides solutions in crude and total fat. So as many of you, I'm sure, understand, crude fat is that free fat easily available, usually extracted through a Soxhlet type extraction, and is a very common method used in feed analysis. And then we also have the more bound fat, which needs to be extracted using a hydrolysis, either an acid hydrolysis, alkaline hydrolysis. We focus on acid hydrolysis here at ANCOM, but we have some other options as well to run the Majano methods. But we have solutions for both total fat as well as crude fat. When we looked at the different methods out there, both the conventional and our competitors, which I'm sure some of you are familiar with, they all require glassware. There is a lot of glassware involved. There's a lot of technician manipulation involved, a lot of time having to sit there while you are letting your Soxhlet reflux. These are images of examples from Gerhardt, FOSS, Buki. They take around 4 hours of process time, do 6 assays per run, and they're still pretty labor intensive, and with, again, using the glassware. So our direct competitor for crude fat determination to these is our ANCOM XT15 extractor. Our XT15 extractor can do 15 samples at a time compared to the 6 that our competitors do. This instrument is also enabled by filter bag technology, which eliminates that glassware. You can do 1 to 3 gram sample type sizes, and you can analyze a fat content of 0 to 100%. So there really isn't a limitation on this. Everything is done automatically. As I mentioned, up to 15 samples per run. It's all computer controlled and done in a closed system. So it's under pressure and elevated temperatures, which greatly accelerates the time it takes to extract your sample. This instrument also recovers solvent, which is a huge benefit both from a cost standpoint as well as an environmental standpoint. It has a solvent recovery rate of over 97%, and it reuses the solvent automatically. So you are able to not only recover it, but it will automatically put it in your next run and continue to cycle through until you need to simply pour a little more solvent in to top it off. Because it's a closed system, no vent hood is required. We have charcoal filters that you attach to this instrument that helps neutralize any vapors. And I have a short video that is going to give you a little bit of an idea of what's going on inside the instrument. So the way we describe the XT15 is that it's an automated Soxhlet type extraction. So this video will give you an idea of that.
The ANCOM XT15 extractor advances and simplifies the conventional Soxhlet operation. The XT15 automates the process in a closed system. 90 degrees Celsius extraction temperatures accelerate kinetics to greatly reduce extraction times. With the ANCOM XT15, samples are prepared and encapsulated in a specially made filter bag. Up to 15 samples are placed in the extractor. After selecting the extraction time and closing the extraction vessel, the user pushes the start button and the system automatically controls the entire process. Solvent is automatically inserted, heated, and refluxed at high temperatures under pressure. Using a high-temperature process, lipid components are rapidly removed from the sample, while non-lipid components remain during a reflux operation. Throughout the operation, the solvent refluxes and siphons throughout the selected time, ensuring that each sample is completely extracted. At the end of the cycle, the solvent is automatically distilled and recycled, ready for automatic reuse in the next extraction run. The filter bags are placed in an oven for a short final drying. And then re-weighed to determine the amount of fat or oil the sample contained.
So as you can see, the XT15 instrument operates very similarly to our Delta fiber analyzer in the sense that the technician really just needs to have proper weighing skills for their sample for diatomaceous earth, if that's needed in the method, to weigh into their filter bags. They place their filter bags in the instrument, and then the instrument does the work. So the technician's able to walk away while the XT15 is extracting your crude fat or while the Delta is extracting your fiber components. And when they come back, then they will dry their filter bags and get their final weight. So both use indirect methods and the values are found gravimetrically. This next section, I want to talk a little bit about how you take then our crude fat extraction and pair that with acid hydrolysis. So for total fat extractions, again, you have the competitors like a Foss, a Gerhardt, Buki. They all, again, run around 6 assays per run, and they're pretty labor intensive, even though they do automate some of the process. They require the glassware. The technician is still highly involved. Our direct competitor to the instruments you saw on that screen is our HCl hydrolysis system. So this system uses our filter bag technology, eliminating the glassware. You can do sample sizes from 1 to 2 grams, analyze oil from 0 to 100%. Again, it's 15 samples at a time in this run. You would go straight from this into our extractor. which I'll show you more on the next slide. It's all computer controlled and done in a closed system. The rinses are automatic, and it's a very small footprint. So traditionally, this is our, what you would generally see for total fat analysis. You have your hydrolysis step, your filtration steps, drying, your extraction step, drying again, and it takes anywhere between 6 to 12 hours depending on what solution you're using for each of these portions. This gives you an idea of how the two instruments I just discussed from ANCOM fit into this timeline. So you start with our filter bag technology. You would use the HCl hydrolysis system for your acid hydrolysis. Takes about 1 hour. We have a rapid dryer, we call it. This is simply a little dryer we designed to allow you to put your samples straight into this and dry for the 3 hours, as opposed to using up your own lab oven space, as well as if there's any residual HCl, that can cause corrosion on your oven. So this rapid dryer replaces that. Then the filter bags would be transferred to the XT15, where your extraction step takes place. As I mentioned, this is done under pressure and elevated temperatures, so our extraction times really are around 30 minutes, maybe 30 to 60, depending on the sample type, but it's very quick. And then again, you have your drying step, and you can do 15 samples with this solution opposed to the 6. A little bit of an eye chart, so I'm happy to share this later, but this also is from the AFCO Check Sample Proficiency Program. This is going to be pretty much the largest validation data that you could find on these systems, because again, they send a sample every month, and we have been a part of this for several years. Everyone runs that same sample in their lab across the country, across the world, submits their results, and then the AFCO program will consolidate and show you how you compare to others. So for total fat, you can see, which it's a little small on my screen, so I'm going to step forward here. The ANCOM method is very competitive here. Our results are very accurate and precise and perform very well compared to the conventional and the FOSS that's also listed up there, and I believe the Majania method. Crude fat, this also shows how we are predominantly the choice when it comes to crude fat extraction. So that again is the XT15 extractor. On average, I need to get a little closer here. On average, it looks like around 50 labs run the ANCOM method per month, compared to 20 to 25 labs choosing the conventional method. So again, ANCOM is predominantly the choice when it comes to the crude fat extraction. Can you click me forward, please? So I'm going to kind of continue into our other solution when it comes to fat extraction, which is going to have 2 applications. Maybe before I jump into this slide, I'll just check the chat real quick to make sure no one had questions on the equipment I just discussed. It doesn't. Oh, there's questions. Okay, so one question is, how do ANCOM instruments handle different types of samples such as grain, oil seeds, and animal feed? So we actually, for crude fat extraction, or if this is referring to the fiber extraction, all the samples are done handled very similarly. There isn't, you're not going to find that you need several different application notes depending on the sample type. Fortunately, our method is able to run all different kinds of sample types using the same singular method. And our crude fat method, as well as our crude fiber method, are official AOCS methods that I can give you those numbers as well. So you're not going to have a lot of different sample treatment or prep when you're running different sample types. The exception to that is sometimes we find with a few different samples when it comes to total fat analysis that the DE ratio that you use in your filter bag will sometimes be adjusted just based on the moisture of the sample and stuff like that. But in general, the samples are all handled the same. So it keeps the process very easy and straightforward for your technicians. Okay, someone is asking, what are the weaknesses of your device? Well, I'd like to stand here and tell you there aren't any because we are very happy with our instruments. We try so hard to think of all the different ways we can improve your life by giving you better automation. So that's kind of an interesting question. I would say periodic maintenance wise, it's very simple. They're easy to maintain. We have instruments that people have bought that have been in the market for almost 20 years when it comes to our fiber instruments. And I literally was talking to someone the other day about how their instrument is probably maybe 14 years old and it's still going well. So we really do pride ourselves on just our service, our help when you do experience a problem, the modular design of our equipment. If you do experience a problem, it's easy for you to be able to, replace a part, for us to talk you through it. So we really do try to make sure we can support you in that way. And I would say it's a benefit and an advantage over the others. What procedure for calibration of the XT15? What is the official method which is used by the extractor to measure fat percentage in the sample? Okay, so maybe, do you know the official method off the top of your head? We have an official AOCS method for crude fat. It's specific to ANCOM. You could look up the crude fat AOCS ANCOM method. I am not remembering the number off the top of my head. I want to say it's, I don't want to give you the wrong one. So, okay, so it's AOCS AM5-04 is the crude fat method. And then maybe Braden can also look up the fiber method for me while I'm answering the other questions. As far as calibration goes of the XT, we run the instruments, do all the QC in-house, all the calibration in-house before the instrument gets to you. So there's no regular calibration needed. Okay, so how do ANCOM instruments handle different types of sample? Oh, I'm sorry, I already answered that one, but there was a addition to it asking if you can do all those samples in one run. The answer is yes, because these are indirect methods. You can run multiple sample types in one run. So if you have 24 samples, say for your fiber run, they can be made up of different sample types and run together. Sometimes for fat analysis, we, depending on the type of sample, you would maybe just space them out a little bit differently or have a blank bag in between them, but that's only if you suspect maybe some fat leaching to each bag. We don't usually see that. Okay, another question is the precision and accuracy when compared to other competitors in determining fat and fiber. So I would highly recommend you take a close look at the AFCO proficiency program data that I had up on screen. We can make that available to you. That is going to show you our accuracy and precision, especially compared to others. It will also show you that we are the predominant choice when it comes to these methods. Our precision and accuracy is very, very high, and a lot of that, or all of it, is really due to our filter bag technology. Because the sample is completely encapsulated and the analysis is performed in a closed system for each system, you are eliminating any of that technician variability, any of that handling error when it comes to sample transferring from one system to another. So I recommend taking a look at that data that I had on the screen previously. In some experiments, we want to use the extracted oil to conduct additional tests. Is that possible for the XT15? So that's a great question. It is not possible with the XT15 because it is an indirect method, so we do it gravimetrically by weight loss. However, I am going to be sharing in this next section our Flex Analyte extractor, which is our newest piece of equipment. This piece of equipment runs total fat analysis and does capture that oil for you, so I'll elaborate on that in these next few slides. Regarding the calibration, is there a documentation or certificate for the device calibration? So I know we do maintain different documentation about the QC checks and runs that are done in-house, and when requested, we're able to provide that. Okay, did you happen, Braden, to find the fiber method number?
AOCS BA 6A-05.
Okay, so the crude fiber method is AOCS BA 6A-05. So those are the two official ANCOM methods. The detergent fiber methods do not have an official AOCS method. However, they are very widely used across the world. Okay, so I'm going to jump into this next section, which someone's question led us into very well. So the Flex Analyte Extractor is ANCOM's most recent piece of equipment. This equipment is very unique. There is nothing else like this on the market because it takes three common steps in many different analyses and puts them into one instrument. So the top portion here, there's a digestion vessel that's pulled out, you see. This is an oven where you can do different types of digestion steps. Everything is automatically controlled. The parameters are all adjustable, such as temperature, volumes. Everything is done under nitrogen, so it keeps your environment inert. The center section here, where you can see the solid phase extraction column pulled out, is the extraction section. So this is where you can eliminate unwanted emulsions. You don't need to handle chemicals and biphase glassware. And this is where your extraction step would take place. Then the bottom portion of this instrument is our evaporation chamber, is what we call it. This is where the evaporation of your solvent takes place under low heat and a nitrogen input. Everything, again, throughout the whole system is under nitrogen, so it keeps your analyte protected. And so when it comes to total fat, across the top, again, is that timeline you saw in my previous slides for the conventional total fat method, your hydrolysis step, your filtration and drying to your extraction step. All of these steps are now completed in this instrument. So you go from 6 to 12 hours of time to about 2 hours total for total fat analysis. And this is just a slide that gives you an idea of, if you say use FOSS, this is how it would replace your FOSS system. So FOSS has a hydrolysis system for the hydrolysis step. You do your drying steps and then their extraction system. Again, all these steps are done in the Flex as one run. I lost my train of thought. Oh, I was going to say one of the reasons we can eliminate so much time is because we remove the additional drying steps. You don't take your sample out of this instrument, dry them, and then extract. You go straight from your hydrolysis step onto your extraction step and then down into the round bottom flask for evaporation. So a couple high-level things about this instrument. It can run 4 assays per run in about 2 hours. Sample size is typically 1 gram for total fat. Again, everything is done in an inert nitrogen environment. It reduces the technician time from 10 to 15 minutes per run. So really the user will simply assemble their vessels, weigh their sample, place it in the instrument and press start. The instrument does not need to go in a hood. We have exhaust lines that you can run to your hood or exhaust system, so it frees up that valuable space. And you have the ability to adjust method parameters, which I will share a little bit more on as we go. So the AFCO proficiency program that I've been speaking of, we take those samples that we receive once a month, and we have also been running them on our Flex. Since the Flex is new, it's not used as much yet in this program, but we are working closely with them to get its own method code on there. But this gives you an idea of how the Flex, noted by the red X, is very consistent and performs very well compared to, our previous ANCOM method that I shared with earlier, the FOSS method, as well as the conventional method. And again, this is data I'd be happy to share. So what's really interesting and great about this instrument, what I was kind of describing when I first made the introduction, is because it takes 3 different steps involved in many analyses, this instrument also performs fat-soluble vitamins extraction. So on the screen here, you see just a pictorial view of how you would weigh your sample. You have your chemical additions. You would saponify. Then you need to extract with a liquid-to-liquid extraction, which involves a lot of shaking and waiting for it to separate. And then you would go on to your rotor evaporator. All of these steps are done in the Flex Analyte Extractor. So again, just like the total fat, your technician would spend their time weighing their sample, placing it in the instrument, and then pressing start and walking away. And when they return in about 2.5 hours, they will have dried analyte ready to reconstitute and shoot on an HPLC or a mass spec to then find your vitamin levels. I think someone might be accidentally drawing on the slides. So if you have some sort of marker enabled, just be aware of that. It looks like there's some blue lines now on the screen, but just wanted to make you aware of that. I'm not really sure where that's coming from, but it's not on our end. So I'm not sure how to get rid of it, so I'm just going to keep going. Does it say a name next to it? It looks like Rasha, maybe you might have something on your, oh, looks like we got rid of it. All right, we're going to keep going on. Thank you for that. So anyway, when it comes to vitamin analysis, the Flex again does 4 assays per run in about 2.5 hours. And also I major on fat soluble vitamins A, E, D, but it also does cholesterol, and this is all done in one run with one method. You do sample sizes depending on the sample. It's 0.5 up to 10 grams. Can you click on my PowerPoint, please? Solvent usage is around 150 ml. It's all done under nitrogen. Again, technician time is anywhere from 5 to 10 minutes, maybe 15, depends how fast you are at weighing your samples. That's really the main labor that's going to be involved in this. You do not need to put this under a hood, and it's very easy cleanup and low maintenance. So validation-wise, we have pre-programmed methods that are on this equipment for vitamins. They're all based on the methods you see up there, so the AOAC method and the 2EN methods. Again, our total fat and crude fat methods are also pre-programmed onto the Flex, and those are based on official methods as well. We've done numerous head-to-head comparisons. We've beta tested at many independent labs for vitamins in particular. We continue to do collaboration with independent labs around the world. And then we have validated this instrument for all food types of the 9 food sectors on the AOAC triangle. So this just gives you a little bit of a visual of that there is just a very wide range that this instrument can analyze. We have not really found a sample that we haven't been able to analyze, and we're pretty excited about that. These charts, again, are just some data for you that was done in conjunction with Eurofins over in Denmark, one of the largest vitamin labs in the world. They ran the conventional method and compared that to our Flex method. And as you can see, the Flex method holds up very, very well. And is actually it's more, because the instrument removes a bunch of that technician involvement, it's even more accurate and precise, and often recovers the analyte more, a higher volume of the analyte, as opposed to, when you get from technician A to technician B, you're going to have a difference in recovery. So for vitamin E, this shows some of the collaborative data we worked on with them, as well as vitamin D. And then we've also run several different certified reference materials, like the NIST reference materials. And you can see here that the Flex performed very well. We're very happy with our RSDs, and we've just found this to be a great solution for both the vitamins and the fat. So I know that's a lot of information. This next slide, I actually have another video that gives you a better idea of how this instrument runs. What the video is going to focus on is vitamin analysis. However, total fat analysis or crude fat is run very similarly. The operation of the instrument doesn't change. It's just basically whatever method you're going to choose on the screen, and then you have the appropriate reagents. The instrument will perform similarly. So this will give you an idea of that.
With the new ANCOM Flex Analyte Extractor, ANCOM technology raises the bar on laboratory innovation. The instrument's revolutionary design and advanced software technology eliminates technician variability and labor-intensive procedures involved in sample preparation for vitamin A, E, and D analysis.
This fully automated system allows the user to run any methods that require saponification, extraction, and evaporation in one integrated unit. The ANCOM Flex Analyte Extractor is easy to use. Following computerized prompts, the user simply assembles the digestion vessels, weighs sample directly into the vessels, and inserts the vessels into the digestion oven. This setup includes the installation of pre-packed SPE columns to support the extraction step. Specially designed glass globes eliminate the need for separate roto-evaporators. The program allows the user to choose from standard pre-programmed methods or create and save their own methods on the touchscreen interface of the instrument. Pre-programmed methods can be adjusted or new methods can be created to meet the needs of many applications. The state-of-the-art software and interface provide the user with full control of the method design and process. During an assay, the user can track progress and dynamic conditions. The interface will show which vessels are being filled, whether draining is complete, which reservoir is engaged, and highlight the current step of the method, all in real-time, up-to-date temperature and pressure data. The ANCOM Flex Analyte Extractor's software includes complete record keeping of all assays, faults, calibrations, and services. Short reports and raw data files can be downloaded for record keeping or further diagnostics. The Advanced Diagnostic Center allows the user to run diagnostic tests on the instrument to support troubleshooting and calibration. Once the user is ready, they can start the assay and walk away. To protect sensitive analytes and eliminate contamination, the digestion vessel headspace and SPE columns are purged with nitrogen. Once the system is free of oxygen, reagents are pumped into each vessel while the sample is mixed. Digestion time, temperature, and pressure are monitored and controlled while mixing. Since no manual transfer of sample is required between the saponification, extraction, and evaporation steps, transfer error is eliminated and precision is improved. After saponification, the sample solution is cooled and transferred through specially designed filters into the SPE column. Water-soluble components are separated by SPE cleanup. This technology also eliminates complications that are typically associated with biphase extractions, such as unwanted emulsions. Evaporation is optimized by an innovative design that increases the surface area of the solvent and counteracts evaporative cooling with a directed heat input. These factors result in fast evaporation while continually maintaining an inert nitrogen environment. The user will be alerted when the analyte is isolated and ready for reconstitution for further quantification on GC or HPLC. This groundbreaking integration of a series of chemical processes vital to fat-soluble vitamin preparation sets ANCOM apart. The ANCOM Flex Analyte Extractor can analyze 4 samples in a 2-hour time period, utilizing limited counter space. Minimizing chemical handling and automating the process increases safety, reduces technician labor, and assures data that is useful, precise, and accurate.
All right, so that video is just a great visual of what is actually happening in the instrument. As I mentioned, it's specific to vitamin analysis, but the process for fat would be very similar. So these next slides is just a quick recap to kind of help put a bow on everything we just talked about, because there's a lot with this piece of equipment. The top portion there that you're seeing is the digestion oven. So that's where either for vitamin analysis, you'll do your saponification, Or for total fat analysis, you'll do your acid hydrolysis. So this replaces those two very manual steps that your technicians would have to use a lot of glassware and a lot of time, really. So for the saponification, we do 75 degrees Celsius for 45 minutes, and for the acid hydrolysis, it's 100 degrees Celsius for 10 minutes. Oops. Under positive flow filtration, there is a filter disc in the digestion vessel that then the sample is filtered through. The saponified sample is filtered onto the SPE column for cleanup. The hydrolysate is filtered to waste, while the hydrolyzed fat is retained on the vessel filter. And then that is pushed onto SPE for cleanup. So the vitamin column will hold up your polar compounds and elute the analyte into your round bottom flask. Then also likewise for total fat, we use SPE technology. I can show you after I back out of my PowerPoint, those SPE columns look slightly different. They're not quite as large. And the fat is extracted from the digestion vessel filter and transferred onto the SPE column for further cleanup. And again, is eluted with hexane into the round bottom flask. For crude fat analysis, you would use essentially an empty SPE column, so there would be no sorbent material in it because it is not needed. So from the digestion vessel, your fat would be filtered, or rather just travel through the empty vessel into your round bottom flask. And then again, the the evaporation oven is where under a low temperature and positive flow nitrogen, your solvent is evaporated, leaving you your analyte. For vitamins, you would then reconstitute this with your preferred solvent and then move on to your quantitative step on your HPLC or your mass spec. For fat, likewise, you can either do the gravimetric analysis if that's all you need, but if you wanted to further analyze the oil, as someone mentioned in the question earlier, this instrument gives you that oil to then take and do fatty acid profiling or other analyses. This instrument is very robust in a lot of ways, and one of that is its software. The software we spent a lot of time developing to give you a lot of versatility with the instrument. So here, this is just an example of how not only is this instrument optimized for the two applications I just spoke about, so total fat and crude fat, as well as the vitamins and cholesterol, we give you pre-programmed optimized methods for those. However, we've also made this instrument with the ability to have custom software on it that allows you to create your own methods. So you see on the screen, there is a pick list of different functions from filling modules to mixing modules, heating modules, etc. You can drag these over and create your own method sequence as you're doing your own research and development. So that is the end of my slide. I'm going to back out quickly and take a look at the chat to see if we have some more questions. And then maybe with the few remaining minutes, I can just show you the instruments behind me quick so you can see them live. So one person is asking, would you please mind to share this slide with our email afterwards? Absolutely. Looks like Al-Katab already responded to that, so that is great. We are recording this, so you will get the recording, and we can also share the slides or the data that was in the slides as well. So I think real quickly, since we have just a few minutes, let me just show you what these instruments look like in real life. So all the pictures you saw on the slides, they're all, pictures of our equipment here, but the room I'm standing in is a working lab that we've turned into a video conference room. And as you can see behind me, we have all of our instruments in this room. This is a really great tool for us not to support, our distributors around the world, as well as our customers, wherever you are. We're able to hop on a video like this and get up close and personal to our equipment, talk you through whether it's a method question or how to run the instrument. We perform trainings this way. We can also help you through any technical service you have. So this room we utilize a lot, and we would highly encourage you to reach out when you want video calls as well. So it looks like we have a couple more questions. Is the device applicable to extraction of fat from all foodstuffs such as egg yolks? Yes. We have analyzed many different samples across the board, and you are able to use this on all sample types. And then, on the rare occasions where some of our customers, more on the vitamin side, because some of the some of the vitamins aren't dispersed maybe homogeneously throughout the sample. We work very closely with customers if they're finding, some sample type that's unique. We will work with you to make sure we get that optimized, but that's pretty rare. Which source of nitrogen does the Flex instrument use? A nitrogen sealer or nitrogen generator? Okay, great question. So for nitrogen, that is really up to you. We use a cylinder in our lab. Many labs do. You would need a regulator on that, and then the nitrogen connection is just on the side of the instrument. We do have labs that use nitrogen generators, so that is fine as well. We would give you the specs of what the instrument needs, and you would just adjust accordingly depending on your source. Okay, so let me just show you real quick the instruments a little closer. I have a second camera here that I just want to show you the ability we have to kind of show you that a little closer. Let me just fix my camera for a minute. Okay, so I just wanted to give you a little bit of a closer view of the Flex. In particular, this is our digestion oven. The vessels are very easy to take in and out. You have a magnetic spinner. We have two types of spinners. This one in particular is just a bar. We have a cross spinner as well. Your filter would go in the bottom of this digestion vessel. You would weigh your sample, and just slide it in place. These ports are for, in particular, vitamin analysis. You can add an internal standard. Let's see, these tops come down and seal the tops of your vessels. And the instrument is going to do a pressure check and make sure you have no leaks, because as I mentioned, then everything is inert and done under nitrogen. So the instrument will let you know if there's any leaks. The center part here, I have two columns that are shown. The larger column is the vitamin column that is used. This is a one-time use. The smaller column is a total fat column. This is a funnel that's just simply an adapter because of the mouth of the of where the fluid gets pushed through. These can be reused. The total fat column is a one-time use as well, and they are manufactured by ANCOM. Then down here you have your evaporation chamber and your round bottom flasks where your analyte is then ready for reconstitution or your oil is captured. You have a reservoir chamber here where you have all your different reagents that you would use for each analysis. We also have a grommet hole on the side of the instrument if you want larger vessels. And then the software, just to give you an idea, is just really easy to use. You select the method you want. So if it's vitamin analysis, you would select your method. The instrument's going to prompt you through all the steps. Once you enter your samples, it'll make sure you have a checklist of the things to follow, and then you press start. Yeah, I think maybe we can take a look and see if there's any other questions. Okay, so can you just move the cursor for me? Thank you. So is ANCOM Flex capable of analyzing heavy metals in different foods and feed products? So that's an interesting question. So we do not do this analysis currently. If you have a specific method you're thinking of, I'd encourage you to send us or send El-Kitab that method. We can have our scientists here in-house take a look at it and let you know the compatibility. We do anticipate this instrument is going to be utilized in many different fields because of its nature and the ability to customize your own methods. So we are happy to explore that with you, and are currently in the process of working with some other customers exploring applications that are unique. So please send your method and we'll take a look. How does the safety mechanism in these devices operate, and is it possible for workers to go past it? What are the potential hazards and the measures taken to mitigate them? So our instrument will do a full pressure check before every run. It does a bunch of different checks before the run, and we have a whole slew of different error codes that will come up on your screen. It'll alert your user, and it'll kind of pause everything until they take action on what they want to do, whether that's to abort their run, to continue on if it's safe. It'll only allow them to do that if it's safe. Likewise, the other instruments I referred to, so the Delta you can see over in the corner here and the XT15 behind me as well, those also have different faults that'll appear on the screen. We make sure those are all, the safety precautions are all built in to each instrument. Did you or one of your customers participate in a proficiency test? If yes, what is the result obtained? So that's the AFCO Check Sample Proficiency Program that I discussed in the PowerPoint slide. So there were, you could see in the different sections, both the fiber, the fat for the XT15 and HCl, excuse me, as well as flex. You can see that data in that PowerPoint, and it shows just predominantly for fiber, crude and detergent, and for crude fat. ANCOM is by far the chosen method to run. For flex, we have run certified reference samples through NIST. We have also run the AFCO check samples as well, so you can see the results there. And then I would also encourage you to look at the data I shared of our collaboration with Eurofins. We are going to be publishing a paper soon with that information as well, so that's something you can keep an eye out for too. We'll be publishing that with AOAC. Okay, tell us about availability of maintenance, consumables, and parts. So we, even throughout COVID, we have always been a company that has stocked our consumables, our parts, and our equipment because we care that our customers are always running and operating. We never want to be the reason that you aren't. So even throughout COVID, we never had a problem with, a backlog or our supply chain because we keep, 6 months to a year of each consumable stocked and ready for you. So you're not going to see a disruption in your service. As far as maintenance goes, we work through our different distributors. El-Kitab was the kind enough to organize this for us, who help provide service, as well as I mentioned this room that I'm in. Our technicians can quickly get on a phone call with you if needed and assist virtually, but then we also have distributors throughout the area. I understand that from your presentation, the instrument is manufactured to extract fat from food to be ready to test in GC or HPLC. That is correct. So the Flex will extract the fat, it'll capture the oil for you, and you can then take that oil for further analysis on your GC or HPLC. If you use the XT15, this does not capture the oil for you. It is all done gravimetrically or an indirect method. I would say the reason people will choose maybe the XT15 over the Flex is for its throughput and because they don't need to do that further analysis. If you need to do that further analysis, the Flex would be a better option for you. Is hexane are suitable for extraction to all foods? I mean, we use hexane in our method. I'm looking at Braden right now to help me out with this one. Right. And in our method, we use hexane to elute onto our SPE column. So if the question is like, would you have to change the solvent depending on what sample you put in? The answer is no. You'd be able to use hexane across the sample types for our total fat method. How long of time from preparing the samples until you get the results? So great question. If you're talking about the Flex for total fat, your technician is going to take about 10 to 15 minutes to prepare their samples, put it in the digestion oven up here, and then they're going to press start, walk away. In about 2 hours, they will have their fat. If you're doing a vitamin analysis, they will put their samples in the digestion oven, press start, and walk away. In about 2.5 hours, they will have their vitamins. In one run and one position, you will get analyte that you can analyze for all vitamins, so A, E, D, and then also cholesterol. You don't need to do those separately. And then for the XT15 extractor, you would weigh your samples. The extractor itself is about an extraction time of 30 to 60 minutes, usually more on the lower end there. And then for the Delta, you would weigh your samples, again, depending on your technician's skill, 15 minutes maybe, put it in the extractor. And then is there a difference in time for crude versus detergent runs for time?
Crude is about half an hour longer.
Okay, so then the detergent, how long is the detergent run? Hour and a half. So you're looking at anywhere from an hour and a half to 2 hours when it comes to the fiber runs. Okay, let me look at this next question. So vitamins are affected by heat. So what is the ideal temperature for the oven? So we follow, our methods are based on the official EN methods, and they recommend 75 degrees C for 45 minutes to saponify the samples. And that keeps the vitamin intact. Again, we have everything under a nitrogen blanket, so it's going to protect your analyte. We find that labs using this equipment for vitamin analysis often actually get higher recoveries than their current process because our instrument does so well at maintaining the integrity of those vitamins. So we understand that's a concern, and if anything, actually, we find that the labs using this will recover more than maybe their conventional method because we've taken out a lot of that variability. So it looks like we don't have any more questions at the moment, and I believe we're a little over our time, so I just want to be mindful of that. Looks like El Katab might have accidentally got out of the meeting, so we're letting him back in.